Good afternoon, class. Today we are going to look at the sum of terms, sum to infinity of a GP. That's what we're going to be looking at today, and it will mark the end of sequences. Okay? The next class we're going to be looking at vectors. That's what we're going to be looking at in the next class. Okay? That's our next topic. So with this now, what is the meaning of the sum to infinity of a GP? Well, let's just go straight forward. See, let me start by the formula. What is the sum of terms in a GP? See, we have, consider this. Consider Sn, sum of terms in a GP, right? So we have A like this. So this is going to be r raised to power n minus 1 over r minus 1. This is only when we use this. This is suitable when r is greater than 1, the common ratio is greater than 1. This is when r is greater than 1, the modulus of r is greater than 1. Okay? So next, or we can have Sn is equal to A bracket r raised to power n, 1 minus r raised to power n, everything over 1 minus r. This is when the modulus of r is less than 1. This is it, right? So for sum of a GP to infinity, we always use this when the modulus of r is less than 1. So we're going to see more of that. Why is it like this? This is so, now, if r is less than 1, the modulus of r is less than 1, then we see that r raised to power n tends to 0 as what? As n tends to infinity. What is the meaning of this expression? We see that this whole thing becomes smaller and smaller. You're going to test it yourself and see. It becomes smaller and smaller as n tends to infinity. Infinity means n becoming bigger and bigger and bigger. N is 1, n is 2, n is 3, n is 4. As n is increasing, this thing diminishes. Okay? So because of that, we have that this one is going to vanish. It diminishes. As n tends to infinity, this very term diminishes. R raised to power n diminishes. And so, therefore, I can have it this way. N goes to infinity, I write it like this. Right? Which is going to be equal to A bracket 1 minus, you see, this goes to 0. It goes to 0. Everything divided by 1 minus r. And so, my S infinity, that sum of terms of this GP to infinity, would eventually become A over 1 minus r. This is the formula for the sum of terms to infinity of a GP. Okay? That is it. So, let's take some simple examples. Find, number 1, find the sum to infinity of 1 over 2, 1 over 4, 1 over 8. This is a GP. We are going to find the sum of this particular GP to infinity. It's simple. If you look at it clearly, the common ratio is less than 1. The common ratio is less than 1, or the modulus of the common ratio is less than 1. And so, this is the solution. What do we do here? We say, since we are finding its sum to infinity, first, we quote the formula. S infinity is equal to A over 1 minus r. Very, very simple formula. Very simple formula. Sum to infinity is equal to a over 1 minus r. So, we now find our a. Here, a is equal to what, somebody? A is equal to the first term, 1. See? Then, what is the common ratio? The common ratio is a term divided by its preceding term. So, this divided by this, or this divided by this, or this divided by this. In each case, you are going to get a half. So, I have 1 over 2 divided by 1, which is equal to 1 over 2. So, or this divided by this is half. This divided by this is half. In each case, you get a half. And half is less than 1. Okay? Half is less than 1. And so, it means that the equation is okay. The question is okay. Right? The next thing is to substitute these values into the formula. Substitute these values into the formula to find our sum to infinity. So therefore, we have, let me take this out. Therefore, we have sum to infinity of that particular GP, sum to infinity of this particular GP is going to be simply, the first term is 1 over the common ratio is half. So it is going to be equal to what? 1 over half, which is equal to 2. See, 1 divided by half is equal to 2. So this is the sum to infinity of that GP. It means that no matter how many terms of that GP you take, if you take 100 terms of this GP, the sum will not exceed 2. It is just approaching 2, it will not exceed 2. So this is the highest you can get for the sum of that GP. If I add more terms here, let's say another term here, that's going to be 1 over 16, 1 over 32, 1 over 64, 1 over 128, 1 over 256, and so on. I am not going to get a sum more than 2. All of them put together will not give me a sum more than 2. That is the meaning, okay? So, let's take another question quickly. Another question says that, number 2, it says, the sum to infinity, the sum to infinity to infinity of a GP is 27. See, the sum to infinity of a GP is 27. If the first term, full stop, if the first term is 36, find R. Find R. Here R is the common ratio. R is the common ratio. So this is what we're going to do now. The sum to infinity of a GP is 27. If the first term of the GP is 36, find R. So in this case, we quote the formula, solution. The formula, you write it first, is equal to A over 1 minus R. This is the formula for the sum of terms in a GP. Okay? So with this formula, we see clearly that S infinity is given. Sum of terms to infinity is given, right? Sum of terms to infinity is given. So it's equal to 27. That means that S infinity is equal to 27. Given, right? Then what again? A is given. A is equal to what? 36. So now I can substitute this into the formula and get my common ratio. Therefore, we have 27 is equal to, first term is 36, divided by 1 minus R. That's it. Okay? So we now cross multiply. Okay, you can cross multiply this. 27 bracket 1 minus r is going to be equal to 36. Okay, so we can solve it in many ways, but I'll just divide through out by 27. So if I divide through by 27, I have this goes up with this, so 1 minus r is equal to 36 over 27. 36 over 27, 9 can go, right? So 1 minus r is equal to 9 here is 4, 9 here is 3. And so r is equal to 1 minus 4 over 3. So r is equal to 1 minus 4 over 3 is what? Is minus 1 over 3, right? Minus 1 over 3. That is our common ratio. Our common ratio is negative, minus 1 over 3. Okay? And then if you check the modulus, is the modulus of minus 1 over 3 is less than 1. Okay? So now, if you check it, it's equal to the modulus of 1 over 3, which is equal to what? 1 over 3. So we are consistent here with this. That's it. So the next thing, let's have another question, and then that will be all for today. Let's solve another question, and that will be all for today. Okay. Another question, number 3. It says that the third and sixth terms, the third and sixth terms of a GP are 2 whole number, 2 over 3 and 8 over 20, 81, 8 over 81, respectively. Full stop. Find A. The common ratio. The common ratio. B. The first term. C. The sum to infinity. The sum to infinity. That is it. Okay. The sum to infinity. Okay, we are given the third term. Solution. The third term is written as ar raised to power 2. You remember this already. Which is equal to, you know this already, which is equal to 2 whole number, 2 over 3. Okay? So, and still equal to, this is 8 over 3. Call this equation 1. Okay? The sixth term is also given. How do we write the sixth term? ar raised to power 5, which is equal to 8 over 81. Call this equation 2. That's it. Now, if we have this, we can divide 1 by 2 or 2 by 1. So I will state it. Divide 1 by 2. Anyone? 1 by 2 or 2 by 1. So we're going to have ar raised to power 2 over ar raised to power 5 is equal to 8 over 3 over 8 over 81. This is what we're going to have. Okay? And so this goes up with this. This goes up with this. We have 1 over r raised to power 3 here is equal to this is going to be 8 over 3 times 81 over 8. So we have this. This is 9. Sorry, this is 27. And so we have 1 over r raised to power 3 is equal to 27. Okay? So r raised to power 3 is equal to 1 over 27. By inverting both sides, add this to 8, r raised to the power 3 over 1, and then this one 27, 1 over 27. So that means that r is equal to cube root of 27, which is equal to 1 over 27, sorry, which is equal to 1 over 3. R is equal to 1 over 3. That's what the question says. The first one, A. That's A. We're done with A. B. In B, what are we going to find in B? In B, we're going to find the first term. To find the first term, take r raised to r equal to 1 over 3, put it in 1 or 2. But it's easier to put it in 1 to get A. Put A equal to 1 over 3 in 1. If we do so, we are going to have A bracket 1 over 3 raised to power 2 is equal to 8 over 3. So we have A bracket 1 over 9 is equal to, this is 1 over 9, 8 over 3. So we have A over 9 is equal to 8 over 3. So when we cross multiply, here I'm going to have A is equal to 8 over 3 times 9. So A is equal to 3 here 1, 3 here is 3. 3 times 8 is 24. 24. So the first term is 24. The last question there, find the sum to infinity. We can see that the common ratio is already less than 1. So sum to infinity is possible, right? C. This is B now. This is B. This is B. Now C. In C, we are going to find the sum to infinity. So you quote the formula like this. Is equal to A over 1 minus R. This is the sum to infinity of AGP. And so we're going to substitute. We have A already. What is A here? Is 24. And what is R? 1 over 3. So we have it. So we're going to have 24 over 1 minus 1 over 3 is 2 over 3. 2 over 3. That's it. Okay? So we can simplify that expression, which is equal to 24 divided by 2 over 3 means times 3 over 2. Is that correct? Okay. So we're going to have, this is 12 times 3 is 36. So the sum to infinity of this GP is 36. We are going to see more and more exercises on this. I will give you tests on this and you will write a classwork today on this. Okay? Thank you. Our next topic is vectors. Thank you.